Okay, so now let's do another example to illustrate the theorem. Okay, so here we have this linear system, and so I'm going to put it in matrix form and then we'll solve it. So this is going to be, we have x, y, z, w. So it's going to be 1, 0, 1, 1, negative 1. So 1, 0, 1, 1, negative 1. And then we got 2, negative 1, 0, 1. Three. And then we got 1, 1, 3, 2, 1. Now we're going to row reduce. So the first thing we're going to do is get rid of these, right? So we're going to do negative 2r1 plus r2. And then we're also going to do negative 1 r1 plus r3. And so that's going to give us the following equation. So again, I'm going to write this down. So the first row is going to stay the same. So 1, 0, 1, 1, negative 1. And then it's going to be what? It's going to end up being 0, negative 1, negative 2, negative 1. Right? Five. And then the third row is going to end up being 1, 2, oh, hold on. 0, 1, 2, 1, 2. So 0, 1, 2, 1, 2, right? Again, just go through the steps. Do it yourself. Make sure you're getting the same answer. Okay, now, let's go to the next one. Now, okay, so let's stop here for a second. Notice, oh, here we go. Notice that if we do another operation, let's say, again, we're going to get rid of this one, right? So what do we have to do? We have to add these. But what do we get when we add these? Well, this goes away, this goes away, this goes away. This becomes 7. We get 0 equals 7, a contradiction. And so we're getting the fact that this has no solution, right? But let's do the associated homogeneous system, right? Oops. Okay, let's look at the associated homogeneous solution. Now we can do this, and what happens? Well, if we go the next step, and we take row 2 plus row 3, then we can continue on, because then we get 1, 0, 1, 1, 0. Then we get 0, negative 1, negative 2, negative 1, 0. And then we get 0, 0, 0, 0, 0. Now, so in this case here, we end up with what? Well, in this case here, what? We have Z and W are free, right? So if Z and W are free, then we're going to get what? How do I want to write this? So if I do vectors, right? So if I do vector notation, we're going to, oh, yes. Yeah, let's do it. So the solution set would be the set, and so we're going to do W or Z. Well, let's do Z first. So Z is going to equal what? 1 no, I'm sorry. So this is the first vector is going to be, our first beta vector is going to be, so again in terms of E, so X is going to be -1, Y is going to be 1, no, 2. Right, now the next one is going to be, because we're dealing with Z, this is going to be Z, so it'll be 0 or 1 and then 0, right, because this is Z, right? So for Y, or for X, it's going to be -1, right? Z right here, -1. Then we're going to have +2 right here, so for X, right? So for X, it's going to be a +2, and then for Z, it's going to be 1 because Z is equal to Z, because it's free. And then of course, there's no W in this, right? Because we're dealing with Z, so that's going to be 0. And then we're going to plus, now we're going to have our other vector, and the way we're going to do that is we're going to go back. So our other vector is going to be -1, right, for W. And then for this one, it's going to be +1. And then for this one, it's going to be 0 because we don't want Z in here. There's no Z, so it's 0. And I have 1 for W. So that's going to be our set, right? Or for the form of our set. So this is what our set's going to look like, right? Notice that we're writing it as a linear combination of our beta vectors plus and our free variables. So why don't we say that? So again, such that Z and W are real numbers. Okay? So again, proving what we set out to prove. Now, but keep in mind, because the original system has no particular solution, its general solution set is empty. There are no vectors of the form P plus H because there are no P's. Right? So again, the solution set is the 0 set for the particular case. Okay? So again, it's just so now in fact the solution set here for the associated homogeneous system is infinite. And again, just nonetheless, because the original system has no particular solution, its general solution set is empty. And the reason why there are no vectors of the form p plus h, right? Because there are no p vectors. That's it. Have a good day.